The F-22 Raptor can truly be called a masterpiece of military engineering. Its designers succeeded in doing a perfect job, combining extremely high flight performance with the latest electronics, all at a time when most countries were only dreaming of a fifth-generation fighter. Perhaps this is why the United States flat-out refused to export it? How did the YF-22 prototype manage to defeat its arch-rival, the nearly perfect YF-23 stealth aircraft? We will be answering this question and others in today's video. The F-22 was the crowning achievement of the American Advanced Tactical Fighter program, which was launched back in the 1980s. Its main goal was rather obvious: provide air superiority to the U.S. Air Force to counter emerging global threats, such as the Soviet Su-27 and MiG-29, also developed in the 1980s. Pioneers of American aviation took part in the arms race: Boeing, General Dynamics, Lockheed, Northrop, and McDonnell Douglas. Each of them presented its own prototype by July 1986, as a result of which military command settled on two options, those from Lockheed and Northrop. 50 months were spent on serious stress tests for the future aircraft, including a series of studies regarding the performance of the vehicles and their flight tests. To keep things simple and to the point, the companies named their prototypes YF-22 and YF-23. However, behind the similar nicknames, there were many differences that became critical when choosing the winner in this friendly air confrontation. To understand why the U.S. Air Force still opted for the F-22 Raptor, let's compare these two beauties. The Northrop team created two prototypes at once. The first, PAV-1, was nicknamed Black Widow II in honor of the Northrop P-61 Black Widow aircraft during World War II, and a characteristic pattern in the Spider's form was set on its fuselage, although the company's designers did get rid of it rather quickly. The prototype was powered by a pair of Pratt & Whitney F-119 PW100 engines, giving the fighter a super cruise speed of Mach 1.43, or about 1,088 miles per hour, so it could maintain that speed without the use of afterburners. Northrop's second prototype, the PAV-2, was given a no less menacing name, the Gray Ghost, in keeping with its coloration. It used YF-120 engines from General Electric, giving the vehicle an even more impressive speed of Mach 1.6, or 1,217 miles per hour in Super Cruise mode. As for the naming of YF-23's rival, the YF-22, many of you will probably be surprised to learn that it was originally unofficially named Lightning II in honor of the Lockheed P-38 Lightning during World War II. Only by the mid-1990s was this thrown out, replaced by the more familiar one, Raptor, and a little later, the Lightning II went to the brand new F-35 by inheritance. According to some sources, the top speed reached by Northrop's creation hit Mach 2, or 1,522 miles per hour, which was noticeably higher than its competitor, the YF-22, which managed to hit the mark of Mach 1.58, equivalent to 1,202 miles per hour. The YF-23 had fixed engine nozzles recessed into the hull, while the creators of the YF-22 preferred thrust vectoring nozzles, so it was less clunky as compared to its colleague. And although the same engines were installed in the YF-22 and YF-23, the latter was predicted to have better speed performance, at least due to reduced aerodynamic drag at transonic and supersonic speeds. The unconventional design of the YF-23 was statically unstable, which complemented the advanced fly-by-wire system perfectly, allowing the fighter to achieve excellent maneuverability. Additionally, it fully satisfied the requirement of the U.S. Air Force to be faster than the F-16. However, the lower exhaust troughs made it impossible to add a thrust vectoring system, so Northrop decided to put more effort into the stealth radar profile of the aircraft. The Lockheed team, in turn, tried to give their best in terms of the aerodynamic performance with the YF-22. Thanks to the adjustable thrust vector, their aircraft could roll at an angle of attack of more than 60 degrees and other equally extreme maneuvers that no other fighter of that time could manage. Distinguished test pilot Paul Metz, who had flown both the YF-23 and F-22, stated that all fighters experience loss of control at supersonic speeds. To perform the same maneuver at supersonic and subsonic levels, the pilot had to deflect the controls even more, which, according to Metz, led to an even greater increase in the trim resistance at supersonic speeds and reduced acceleration and turning characteristics. The F-22 was able to compensate for this resistance not with the help of a horizontal tail, which was the classic approach for designers, but by changing the thrust vector. With a little forward thrust change, the F-22 continues to have relatively low drag at supersonic speeds. But resistance is only part of the benefits of this fighter's features. By using the variable thrust vector to control the pitch during maneuvers, the pilot could use the horizontal tail to roll the aircraft during combat with the enemy at low speed. Metz claims that this ace in the F-22's sleeve markedly distinguished it not only from the YF-23, but also from the legendary predecessors like the F-16 Fighting Falcon and F-15 Eagle. Speaking of the speed and maneuverability of fighters, one can't help but notice their appearance. In this aspect, the YF-23 undoubtedly has a more subtle form than its counterpart. The engine's special design with ventral exhaust chutes significantly reduced the aircraft's visibility on enemy radars and search-and-track infrared sensors. Furthermore, the diamond-shaped wings of the YF-23 had a smaller profile than the wings of the prototype from Lockheed, which were very close to classic fighters. Due to its non-standard design, the Northrop is still considered one of the most inconspicuous fighters ever created. But what really came as a pleasant surprise for the aces in the YF-22 is the avionics. While the cockpit of the YF-23 is almost identical to the F-15E Eagle in terms of technology spectrum and component layout, Lockheed installed 5 LCD displays and many other features in the YF-22 ahead of the PAV-1 and PAV-2 electronics. The finishing factor was the joystick, located on the side rather than in the middle like the YF-23 and most other fighters, which many pilots found more convenient. The range of the YF-23 was also impressive, about 2,800 miles versus 1,800 miles for the YF-22. The flight range was one of the main requirements of the command for the prototypes of the Advanced Tactical Fighter program, and in comparison with the Northrop model, the only thing left for the Lockheed device was to say, "Hold my beer." The USAF still believes that the YF-23's endurance could be a good reason to resurrect the Northrop legacy for the foreseeable future. Okay, but what about the weapons? The YF-22's main missiles were located side by side in the shallow internal compartment. This decision was simple and extremely practical for the AIM-120, but not too flexible since after the installation of missiles in the compartment, there was not an inch of free space left. The gun bay in the YF-23, by contrast, was deep and long. The missiles were supposed to be placed in groups and a rack was required for efficient use of space. This, of course, added its own complexity and risks to the Northrop designers, so it was regarded by the command instead as a clear flaw in the model. However, among the main reason for the US Air Force's refusal of the YF-23, one can't help but mention such an obvious and stereotypical thing as money. The command has never liked to scatter taxpayer dollars. Therefore, in the competition between the YF-22 and YF-23, the cost was not the last argument in favor of the final choice. Due to less emphasis on stealth and a standardized airframe, the YF-22 was generally a cheaper and less risky design than the exotic YF-23. Of course, now it would be crazy to talk about the cheapness of the F-22, but in comparison to the YF-23 at that time, this factor was quite relevant. At the same time, military experts say that the Northrop prototype would be 40% cheaper to maintain than the Lockheed aircraft, and each hour of flight of the Northrop fighter required 8 to 10 hours of maintenance. For the NA-22, this figure ranged from 35 to 60 hours for every hour of flight. Without R&D, the YF-23 would most likely cost $164 million, while its competitor cost only $150 million, also without R&D. In other words, completing an order for 187 Lockheed aircraft would save the US Air Force $2.6 billion. The reputation of Northrop in the 1990s, which was suspected of fraud in testing, suspension of contracts, and fines, also affected the selection of the winner. The team's work on the iconic stealth symbol, the B-2 Spirit, resulted in huge budget overruns, and the Air Force was rightfully nervous that a similar bad experience could be repeated with the promising YF-23. And of course, we mustn't forget the power of marketing. Lockheed put the YF-22 through hell in a flight test that demonstrated the YF-22's dogfighting and maneuvering abilities, impressing the Air Force more than the Northrop team. Although the Northrop engineers had no equal, as stated by Metz, they unfortunately did not understand how to profitably file and sell their creation. This could have potentially been the final blow to the YF-23. The ATF program was originally valued at $44.3 billion, with a purchase price of $26.2 billion as of the fiscal year 1985, and a total of about 750 aircraft purchased under the program. By 1997, funding instability had reduced the total to 339, eventually dropping by 2008 to 187 active F-22 Raptors and 8 test units. Numerous new technologies implemented in the F-22 have resulted in significant cost overruns and delays. At the same time, many features were delayed until post-maintenance updates, which reduced the initial price of the fighter but increased the cost of the program. As of 2011, when the last F-22 rolled off the assembly line, spending on the program had already exceeded $67.3 billion, of which $32.4 billion went to research, development, testing, and evaluation, RDT&E. The remaining $34.9 billion was for procurement and military construction. Okay, but what exactly is the reason for the ban on the sale of Lockheed's creation to other interested countries? After all, the very same Lightning II was quietly sold to everyone. Under U.S. federal law, the F-22 cannot be exported to protect its stealth technology and classified features. Congressman David Obey was very concerned that the aircraft's technology chips would be uncovered and adapted by U.S. enemies, so he made a corresponding amendment to the 1998 Department of Defense Appropriations Act. In this regard, countries that were interested in American fighters before the advent of the F-35 were forced to purchase earlier devices, the F-15 and F-16. In 2006, Congress upheld the ban, but despite this, by 2010, one of the laws that was set required the Department of Defense to report on the costs and feasibility of the export version of the F-22 and their potential impact on the U.S. aerospace industry. Although the F-35 used part of the technological legacy of the F-22, it was still initially created to be more flexible and affordable for sale. Additionally, almost every country that has previously shown interest in the F-22, Japan, Israel, and Australia, has already acquired an F-35. In 2018, there were even rumors about the possible provision of a hybrid design by Lockheed Martin to the Japanese Air Force, which includes elements of the F-22 and F-35, but since then there has been no further information about this. To prevent the F-22s from rusting away, they are regularly updated. Just think about the unique concept in the F-22 X-44 Manta, multi-axis no-tail aircraft, an aircraft controlled only by vector thrust, or the FB-22, an equally daring project to create a stealth bomber, the design proposal of which Lockheed Martin has undeservedly shelved. Fighter upgrades and improvements consist of software modifications and hardware improvements or technical mandates, recorded in numbered increments, as well as operational flight program software updates. The first aircraft with combat-ready Block 3.0 software took off back in 2001, and the number of updates to the Block series has already reached 35. Increment 2 was the first global modernization program. Since 2005, it has allowed all Block 20 and newer models to use JDAM. Just 2 years later, the advanced AN/APG-77V1 radar was certified to include air-to-ground modes, followed by Increment 3.1 upgrades for Block 30 and later fighters, providing improved ground attack capabilities thanks to SAR radar, synthetic aperture radar, with radio direction finding, DF, electronic attack, or EA, and integration of small diameter bombs, or SDB. In parallel with this, in 2012, the Lockheed team worked on solving the problem of oxygen starvation by installing an automatic backup oxygen system and a modified life support system. Increment 3.2 was divided into two parts. 3.2A focuses on electronic warfare, communications, and identification. 3.2B includes geolocation improvements and the latest stockpile management system to handle air-to-air missiles, AIM-9X and AIM-120D. Along with 3.2B, they also added to the aircraft an open mission system processor, ground collision avoidance system, and integrated the agile methodology, which has since become a trend among software developers today. The planned addition of the multi-function advanced data link was cut after much discussion due to critical development delays and lack of distribution across USAF platforms. The Tails Scorpion helmet-mounted queuing system, successfully tested back in 2013 on the F-22, has also fallen victim to cutbacks due to funding constraints that delayed its development. A new package of upgrades and improvements is currently under active development and involve the following: installation of new sensors and antennas, long-range IRST, the ability to work with manned and unmanned aerial vehicles, a helmet-mounted display with an advanced warning system, IRST functionality for the AN/AAR-56 missile launch detector, a more durable stealth coating based on the F-35. Also, the F-22s in service underwent a $350 million structural modernization program to solve the problem of improper heat treatment on the titanium in some parts of the airframe batches and the addition of 8,000 more flight hours to service life. And while the U.S. Air Force regularly mentions the planned ending of the Legends operation, which is gradually fading into decline, some of the improvements developed under the ambitious Next Generation Air Dominance program will be applied to the F-22 fleet. So do you think the Raptor will be able to get a second wind at the expense of NGAD, or are the days of this lizard predator still numbered? Be sure to share your opinion in the comments below. And if you enjoyed this video, please leave a like and subscribe to the channel for more content just like today's. Thanks, and we'll see you in the next one.